everybody. This is Heitor Lessa Specialist Solutions Architect, and this is Jason.
Hi guys.
Welcome to Build on Serverless on Twitch. This is a new series that we're going to help you understand servers in a more in-depth, where we're going to code something from scratch, make some mistakes, and of course, have you to help us actually fix some of those problems. Some people will call this as a live Stack Overflow. We can actually call anything we want, right? As long as we fix those problems.
You can't script the errors, though.
No, you cannot. Okay, cool. So I'm not sure how familiar everyone is on the SAM and all the tools we have. So we're just going to give a one-on-one very quickly on the tools we're going to use. And then we crack on and start coding as quick as we can. If you can see my screen properly, this is the project called Serverless Application Model, or SAM. SAM is the basis for pretty much everything we're going to do today. It provides you a superset on top of CloudFormation to easily create serverless applications, design how they should behave, how they should do from an infrastructure as code perspective. And we're also going to talk about serverless application repository. We built it, and you should be able to use to get an idea how a serverless application looks like. Maybe in Java, Python, Node.js, but Python is the best. So I would say go for Python. That should work out.
Go's quickly making a comeback then.
Cool. If we go for the first one, have a quick look at the serverless application repository. Before we jump into the SAM, if you click on that button to look up for serverless applications, as soon as that one opens up, maybe it's here we go. You will be able to see a bunch of applications like this. Hopefully at the end of this particular episode, we will try our best to finish the app and publish this in this repository. So you can go and hack around anything you want to do it. If I were to show something like look up for Python, I will be able to see a bunch of apps over here. And if I look for Java, it will be the same thing, or web applications, and so forth and so forth. The idea from here is that once you click in one of those apps, you'll be able to see everything the app will do for you. A license, because we care. How do we package that up? How do we use that application in the first place? And you actually deploy the application from the console. Everything works just as fine.
It's kind of one-click push of a CloudFormation template, isn't it?
That's right.
Or a SAM template.
Yeah, so when you click in deploy, actually, this will, behind the scenes, we'll launch a CloudFormation stack, and we'll handle all that for you. If we are click on deploy over here for now, just to give you a sense of how the experience would look like, you will see the permissions that the application actually needs, even the SAM template actually that person used to publish that.
Okay.
So we're going to try to mimic that at the very end.
So I can deploy it from here, have a play with the sample application, then when I'm done, go to CloudFormation and just delete the whole thing.
Absolutely. Okay. And even the cooler thing is if you look at the top, there's source code URL, and you even see where the source code coming from. So you may want to have a look at the source code before you deploy anything else.
Cool.
Okay, so this is the serverless application repository. And if you go back in here, SAM provides you a bunch of examples over here. So instead of actually going through multiple tabs, I'm going to use a super cool extension called Octo3, which allows me to do this. So I don't have to keep moving around. What we're going to do today is one of the examples called Encryption Proxy. So it's under examples, the year, and then Encryption Proxy over here. You actually also have a bunch of others in here. Let's say if I were to pick up a API backend. If I were to click over here, I would see a SAM template that we're going to write that down and going to explain to you what every line actually means. But this is to give you an idea what a hello world actually looks like. You will see a function over here where it is Lambda. You define what programming language you're going to use, in this case Node. You define where the code is from. So in this case, it's coming from source. And also, how is this function going to be invoked? In this case, API gateway. So if we call /resources /anything, that will invoke that Lambda function.
Mm-hmm. Okay, cool.
So in our case, our is a little bit bulkier in that sense. The encryption proxy, what it does is it's an API that provides you an encrypt and a decrypt. Any data that we send to the encrypt as a JSON will be returned as an encrypted data. We're going to use a service called KMS that allows you to simply encrypt or decrypt data in a much more simplified way. It's still using the heavy security requirements like a HSM, but in a more simplified API. So the next piece, so we're going to start coding and doing all this, is a project that we published actually today. So I'm sure you haven't seen this, so that's new for you. So under AWS Simples, there's something called cookie cutter-AWS-SAM-Python. If you haven't seen this cookie cutter before, it's nothing more than a file that basically called cookie cutter.json. It is a template engine that will read this file, ask a bunch of questions, and also the values actually become the default values. So kind of makes it easier. And based on those questions, based on those answers you give as an input, it will generate everything inside this folder over here. So that we can have a function already done for us, a SAM template with a bunch of other best practices, even some unit tests or something like this.
Okay. So this is the templating engine we're going to be using today for building out a Lambda API gateway project.
That's right.
Cool.
It's actually super easy to start with SAM, looking for hello words and everything else. But if we were to implement all the best practices we are aiming for today, that will take a little bit while, more than 1 hour in that case.
Okay.
So we're going to try to use this as a means to accelerate the scaffolding project for us.
Yeah.
And by the way, this is not just for Python. So as long as you have this cookie cutter JSON, you can do for any language, any file, anything at all.
And I can, as say, a business or a project team, I can take this, create my own customized template where all of my gateways are going to have encryption and different certain features turned on. And that way, as a new project team, I can just use cookie cutter or similar tooling to get started right away and then just focus on my capability, my functions, and my innovation. I don't need to actually build the business standard API gateway.
Absolutely. The whole point of this is if you want to go ahead and fork this, just click on that button on the top right and change for whatever language you need to use or all of these other pieces you want to make sure that every developer, when they start a new project, all your security controls, all your practices in general goes right there. And that is also true for any infrastructure as code, building a pipeline or pretty much anything.
Okay.
So how do you use this? First, you need to install a library or a tool called Cookie Cutter. So if you want to follow with us, you just do a pip install cookie cutter. If you are on macOS, you just do a brew install cookie cutter. Or if you are following the news more recently, Python community is changing to something called pipenv, which actually brings a lot of interesting features for us. And this is the first time it works on Windows as a first-class citizen. So you can install this cookie cutter using one of these tools. Because I already have it, let's just crack on. So if I were to do this right now, I would say cookie cutter and then the URL. That's it. Let me just increase my screen now just a little bit. And though that JSON, those keys on that JSON is actually not right now is the input is actually asking me. So if I were to say simple crypto service with some space, I would just get all those space being stripped. And I could say this is a simple crypto service that leverages KMS, Lambda, API Gateway, and much more. Okay? And this is the interesting part that will actually help a lot in accelerating those projects. Do you want to include API Gateway? Well, we want. Do you want to include Xray? So tell us about Xray.
So Xray is a great way that when you start to get more and more Lambda functions and when you start to use more AWS services, if you need to start to basically p-trace your Lambda function, Xray is going to be a great way to do that in terms of understanding how much time you're spending in different functions in your code base, what endpoints you're invoking. Here we're going to be talking to the key management service. We might also be talking to DynamoDB for other projects and similar. And it's going to give us a great way to kind of get some introspection into what's going on inside of our code as it executes, yeah?
Absolutely.
Okay.
If we go past this, it asks us, do you want to include safe deployment? Well, if some of you have heard about canary releases or blue-green deployments, all of these type of deployments make a lot of sense in general for production, because you don't want to simply start pushing the new code and cut over all the traffic at once, because maybe you have a lot of customers already using it and you want to make sure you can test a percentage of the traffic or something And if that works, then you can move more traffic until you are 100%. So in this case, we're going to do the scaffolding for you and to show you what it takes to actually do this in SAM.
Okay, cool.
And you don't need to do this, but I'm going to do this because it automates a lot of my stuff in the boring pieces. We're going to include experimental make file. So if Sanaf is actually on the stream, he was actually saying that he felt dizzy trying to read and understand the make file. So that's just coming from C, folks. That's okay. So if we go to this new folder that we just created, let's open up an RDE and let's crack on. If you can see this, you will see that folder structure that I showed you on GitHub. It's already here. So if we go to the README file now, we actually tell you all the requirements you need in order to get productive. So of course you need AWS CLI so you can do some deployments. You need Python. You need pipenv installed. That's a requirement for now. And if you want to do local development, we ask you to run install actually Docker and some local. So actually, while we are here, let's actually open up quickly the SAM local. So I don't know how many people seen SAM local. I'm not sure about
Probably not many.
Okay. So the SAM local, if you haven't seen this, is a way to read that template.yaml and actually instantiates an API gateway locally and also Lambda functions. So we're going to try to do this in order to speed up our environment and our life cycle as well.
Okay, so SAM local is a way to locally test and execute environments or execute API gateways and Lambda functions without actually deploying anything in the AWS.
Exactly.
Okay.
If you actually if you actually scroll down a little bit here, you will see an example that was actually done by Paul Maddox and also Sanaf who work on that project, and also Pelayo if you are on the string. So essentially, SAM local will read the index.js file, which is a Lambda function. It will read that template.yaml and will execute as a Lambda function. Behind the scenes, actually it uses Docker and it will actually mount a Docker volume with that project, and then it will be able to invoke the Lambda function locally as well.
Okay, cool. What about if I'm using other services like DynamoDB? How am I going to be able to run tests if I'm using things beyond just API Gateway and Lambda?
Sure. So DynamoDB in particular, we have something called DynamoDB Local, if you haven't seen this. So DynamoDB Local, I'll just put this one over here. It's a jar that we actually offer to you, and you can also run that as a Docker container.
Okay.
So someone on Docker Hub actually did this, and you can simply run as a Docker container, and you have most of the features of DynamoDB right there.
Okay, cool.
Okay, so if you go back in here, the only thing that asks us afterwards is that, well, we need to install dependencies. So if I just copy these two commands, and then if we run this now, because I'm using Visual Studio Code, since February, actually, they made an update that now they automatically recognize your project has pipenv. So all the virtual environment, all that stuff that was difficult for Python developers, is actually solved by pipenv. If you just do pip install flake or pylint or something like this, it will look at your pip file, install only what it means a developing package or developing dependency, and all your virtual environment, everything else is already abstracted from you.
Okay, excellent.
If I already installed all of this, I would see my pip file. If you're new to this tool, you will see the package that I was trying to install, and you will see the dev package I'm installing PyTest, and also a plugin for doing line coverage in a unit testing perspective. If I open up pipfile.lock, you will actually see a SHA and every dependence we have for that particular version, the hashed, and we can be sure that the next time we install this will be exactly the same version, so we pin that, very similar to Node.js NPM or Yarn for that sense.
Okay, cool.
So that's a big improvement actually from coming from pip if you are coming that way. So as we've done this, the first step you can try is we also provide you a simple unit testing to show how you could unit test a Lambda function. So if you just actually copy this now and say pipenv run Python PyTest and all this, it will actually execute the tests under test, and we can see how that actually works. The interesting piece though, if you were running virtual environment in the past, you had to activate that, run some commands, and then deactivate. So that all of this was a bit clunky. So now with pipenv, you can simply say, I don't know how big that my terminal is, but if you simply do pipenv run, anything after that will actually be executed in the virtual environment.
Okay.
If we look at our tests now, so you can start writing the code, is you will see a library called PyTest, which I'd say arguably is the best tool out there for Python developers. You run unit tests, functional tests, and everything. And we actually import our Lambda function exactly the same way we would do for any other code. Of course, we use a fixture for unit testing to make sure that we can use that in multiple tests, in multiple unit test cases. All we are doing here is returning what API gateway would actually inject if our Lambda function were supposed to be invoked. We could also do this by some local, but for now, just hold on. And then in here, we simply say, well, call our Lambda handler with the API gateway event, but no context. We don't need that for now. And if the return is 200, and if the body return is hello world, then it means actually it works. So testing is nothing else exactly the same way as you normally do.
Okay. All right.
So we got this done. If we continue to go for our README, you will see that we explain a little bit about the packaging, how the packaging works in SAM if you're used to this. If we open up our SAM template, one thing that happens is that all of this is actually already commented with links exactly where you can find more information. So you don't have to keep navigating through the GitHub or through Google. Everything you need to know to get started and get as close to production as possible, that's what the cookie cutter did for you. If we look at the function itself, as we were actually showing that previously, I have a simple function called first function. And then in here in the code URI, I actually tell SAM and also some local and every project in between where to look for my files. Mm-hmm. If I were to look here, I wouldn't be able to see any build file here or folder. And of course, if I were to do some local development, that would fail. So how do we do this? I will show you the boring piece first, and then we'll just automate all this, and then we crack on. The way you do this is because pipenv is a new tool, and it doesn't allow you to install dependencies directly into the target directory or a folder, we need to convert this into a requirements.txt, the old pip, install that, and then we should be able to see everything in there. And of course, we need to copy our Lambda function code into the new build folder. Mm-hmm. Node.js is a bit different. It doesn't have to go through that process, but this is how it works actually for Python developers.
So now so I see that it's building a lot of packages, and as you said, it's going to put it into the dev folder. So when this actually gets uploaded as a Lambda function, what's going on there? What's happening behind the scenes? Sure.
So what happens in there is Python for Python developers, for Python functions, different from Node.js where you have a file and then you have node modules. All your modules are actually there. For Python in particular, it expects you to have a flat folder or a zip in this case with all your dependencies and your application at the same structure. Mm-hmm. So if we were to, let's say, create a zip with only this app PY and the build as if there was the dependencies in there, that wouldn't work. Okay. It could work if we were to do a workaround and add a sys path inside our code, but that's a bit hacky and we don't want to keep changing our code. Mm-hmm. We want to develop the same way we are used to develop. If I go to this build file, this build folder in particular, you'll see all the dependencies you list, mm-hmm. Barto, AWS SDK, and including the function in there. That means if we create a zip file right now from this particular folder, we should be able to just deploy on the console. Okay. And that would just work.
Okay, cool. And I mean, do I need all of those libraries just to create a Lambda function? How simple, how complex can I get with Lambda?
Okay, so for now, we're going to show you in a minute about the code itself, but you can go ideally, you should go as lightweight as possible. Your function should only do one thing and one thing really well. Mm-hmm. Very similar to the Unix philosophy in that sense. But you could definitely do something like, I've seen customers running TensorFlow, or you see all types of customers actually doing all of these pieces. So you look at Agero, for instance, they're doing, I wouldn't say machine learning, but they're actually doing a lot of analytics from cars that are driving from an insurance perspective. Mm-hmm. And you want to check if the car is actually deviating, the driver is deviating from the road or something like this. So all of this requires a lot of libraries. So that can be that complex. But you also see customers actually running web applications or adapters like Loggly, for instance. There's many different forms in that sense.
Okay.
If we continue down the road here, we created already the requirements. We installed all our pip dependencies, and then we copy our application. From here, we're not only ready to create a zip file and deploy, but we're also ready to do some local development. So let's see how that looks. Some local, when you actually run for the first time, you will see a bunch of actually commands that you are able to do it. You can generate events, like if I do something like generate event as an API, I could also generate a fake event for S3, Kinesis, Dynamo, so I can pipe that into an invocation for a Lambda. So that kind of simplifies some of those functional testing or integration testing in that sense.
Okay, so this is creating the input event that you want to pass to your Lambda function.
Yeah,
testing.
Let's
okay.
Let's actually give it a try. I think we have enough time. If I just create something like, let's say Kinesis. If I just generate a Kinesis event, you will see this is exactly the same event that your Lambda function would actually receive. Mm-hmm. So what I did actually in the test was nothing more but actually going to unit test, generating an API event, and then going over here and creating as a dictionary in my Python.
Okay.
So that I could use for my testing. Now that I have all this, going back, what I need to do local development is I could invoke the function only once. So I need to pass a JSON and then just call SAM local invoke and the name of my function that reads from my SAM template. So let's do this now, and then we go to the SAM template. If we do this, hopefully, we should be able to get a response. Because I already have the Docker container already pulled in my laptop, I don't need to download Docker container again. So that works, that shows you that it works just fine as a simple SAM invocation. But actually that can get more interesting. I could do SAM local start API, and that will actually read my SAM template and see if I have any events. If I ever define an API gateway there, it means SAM local can mimic the API exactly as I define. So as I wrote there, you can see that that is a localhost 3000/first/whatever. If I try over here and say first is not found because it's expecting something else, because it's expecting anything, if I would just say type this, I got a hello world.
Okay, so that's creating an API gateway locally on your machine.
Exactly, and not only that, you can see exactly the start request, the end request, and how much memory your function actually consumed, and all of these pieces as well. What is this magic? How does that work, right? Before we do something more complex. Under events, in the SAM template, you actually define how your function is going to be invoked, which we mentioned previously. That could be an S3 bucket, that could be an SNS topic, a Kinesis, or something like this. In this case, we are saying that the type is a API. So it's calling from an API gateway. And in this case, we are using first and whatever using any method. So if I were to remove this now and start slowly build our encryption proxy, we could say that this path should be encrypt. And without going for post yet, let's just leave as any. If we were to do this again and say SAM local start API, you see that now I have a /encrypt over there.
Mm-hmm. Okay.
That obviously, if you are running Node.js, you would also get the benefit of having hot reloading. And it's something that I was quite envy. I wanted to do that for Python as well. So that's why I came up with the makefile and work with a lot of people internally as well to get this to work. So now we're going to stop the boring pieces about copying and pasting commands, and we're going to start using automations. Installing dependencies and copying your files from there to whatever, that should be automated. This is the boring piece. I actually believe that anything that's documented or can be documented, you possibly automate that piece. Down below, we're going to follow some deployments and something more complicated in general, but we don't need to go for now. Let's actually let's actually code something, because my fingers are actually quite tingling now. So let's say I'm going to use this makefile for now. If you are running on a Mac OS or Linux, that makefile should just work for you just fine, as long as you have those requirements. If I type make, I would see a bunch of examples on how I can use this make. So for now, I just want to clean all this. And in this case, I'm just going to say first function as a service. what this will do is we'll clean up everything that I have in there. And what I'm interested is I want to store all my dependencies. I want to not only copy those files across, I want to make sure that I can clone those files. So I don't have to keep, every time I make a change in my file, I don't want to keep copying the files from source to destination to build. I want to stay right there, make any changes I want, and that should just work. So if I now hide this terminal and I go to my app.py, I see my Lambda function here, which I can explain to you in a minute. But if I were to say, let's say test over here, inside my build folder, I will see my file called app.py. And you see that as I change something in either direction, they actually get updated. So now I can totally forget about what's inside my build and just start coding exactly as I want. Okay. So that my GitHub repository or my code commit or any Git actually becomes a lot cleaner in that sense. So that's one of the tricks that you can get from the cookie cutter. You asked about the Lambda functions, how big that is, and what is it really? So let me just actually remove this file for now. Inside this, if you haven't coded your Lambda function yet, so I would say go for it, is all we do here is actually we're just importing our libraries, normally Barto S3K, which is just an SDK for Python. We import JSON, obviously, and we import something called Xray SDK. So that is exactly what you mentioned. That's going to give us the distributed tracing. So we can see what our function did, who we talked to, how long it took, and if there was any issue whatsoever. And this is a helper function from the Xray SDK that would essentially look up for any library that it does support natively, like Barto or requests if you're familiar with Python. And it will simply wrap all those methods and it will just start tracing everything. Okay. We don't need to do anything more complex than that. If you are interested, as usual, anything that this cookie cutter creates has a link to the documentation. Next, we create a Barto tree session so we can start initializing some connection. So in this case, we're going to do something like, we're going to start with our KMS client. And then here is our Lambda. Lambda really is as simple as that. You have a function as an entry point. You receive an event, whoever is calling you, and you receive a context. So a context will be a way to give you how long do I have left before my container, my Lambda function actually dies. So the max is 5 minutes. So you can run up to that one. How much memory do I have? So this could be useful for finance calculations or checking out on memory or storing something in memory, see how much you have left, this type of things. Okay.
Or sending a notification if you're about to time out, but you haven't yet completed some bit of work.
Absolutely. Because you also get the logs and who created that function, everything else. That becomes quite helpful.
Okay.
Because we are using API Gateway to invoke that Lambda function, we need an interface that we have to agree. So in Lambda function, in this sample is we have to return a status code and we have to return something in the body. Optionally, we could also return a header. But for now, this is how it would work.
Okay.
And this is a little bit more advanced it's all about Xray, but we're going to get that in a moment. So for now, I'm just going to comment that because I don't need that for now. What we need to do is we need to use KMS to actually encrypt anything that we send to. So of course, we're going to start with using a function that receives any data and obviously receives a key, right? So for now, we're just going to pass that over and we need to know how to encrypt that. I presume you probably also don't know by heart how to call that, right? So how would I do this? Let's go to the documentation. That's exactly where I would spend most of my time. So in Barto documentation, you see everything from here. So if I look up for KMS now, I would see KMS is right over here, and I can see a list of methods that are available for me. For now, I need encrypt and decrypt. Let's do encrypt first.
Okay.
If I click in encrypt, what that tells me is I need to pass a key ID as a parameter, plain text, encryption context, and grain tokens. However, I may not need all of this. If I skip scrolling to parameters, I can see what's really required. So for now, we need key ID and a plain text. So let's do this. I'm going to copy this for now. And I just want to do something like this, actually. Because Python has this indentation, we want to make sure we don't, screw anything up. So we don't need this, and we also don't need these tokens here. We need anything that we send as bytes. So in this case, we just kind of say bytes data, and then we also pass the encoding, which is in this case is UTF-8, and we also need to pass the key. So this will also actually fail because I'm saying client.encrypt. That should be KMS.encrypt.
Right, okay.
This is something I kind of learned from the last time I tried this, and then it was a bit embarrassing. So hopefully you're getting the good version of it now. So if we try to encrypt this, we hopefully will get some sort of a data. For now, don't worry about how ugly this is going to look like. We're going to clean all this up. So I want to look up what is the return from this. I could obviously cheat peek and go to return response, and I should receive a ciphertext blob and a key ID. Mm-hmm. I could get that data for now, but let's just try that and see if that works. So if I were to do something like this for now, it would be something like encrypted payload. We need to send a sort of data, so hello. And we obviously need to pass the key. So I'm just gonna do this to make it more beautiful, because I know there are some Python developers out there and they might struggle me, or if I do something like this. So if I do this, I will be able to do, what is my KMS key so I can encrypt. I already created all this, but we're gonna create it afterwards. So hopefully I'm not gonna disclose anything super sensitive in here. This is my throwaway account, by the way. This is my demo account. So ignore anything else that you see that doesn't really belong to the session. If I click in encryption case, I simply went to my IAM console. We're gonna use Ireland as a region, because that's where I spend most of my time in Europe. And I have a key ID here from demo. So I wanna use this function over here. So if I just use this hard code this for now, don't worry, security folks, we're not gonna do this. We're gonna use environment variables and everything, right? So if we try this, and let's say we actually, that's just well, we have to return this, right? You were supposed to help me with that one. So if let's say we print this out and we continue to return hello world, just to understand what sort of data we're dealing with. So if we try to do this, we could run some local right now. We could do make run that would essentially we do some local start API. For now, let's just do make run. I'm sure something's gonna go wrong, but that's how we're gonna fix it and we're gonna learn from these mistakes. So if I go back again to my encrypt, yeah, I got my first 500. So let's see how that looks like. So it's complaining about the not found exception. So this is, let me have a look. So here we go. So this is the first one. It seems that we are looking at the wrong region. So I could definitely have some local to do all of this, but for now I'm just going to become lazy, and I will go and define this in my session. Region name, and then I can define this. And because my code is already there, I don't have to keep stopping some local all the time. Let's give that a try again.
Is it worth mentioning real quick where the Lambda function is initially getting AWS credentials from?
Absolutely. So in my setup, I have multiple accounts already configured in AWS CLI. Mm-hmm. So some local is actually supposed to get from there or from the environment variables that I have. Okay. Because I have multiple accounts, I tend to use a wrapper to just export all my credentials to environment variables. So that's some local works, and any other tool that I'm used to, it simply works.
Okay, so the Lambda function that's running in a Docker container spun up by SAM local is running with the credentials that you've got defined, same as you do for AWS CLI.
Exactly.
Okay, cool.
So if I were to try it again, let's have a look. So this is where things start to get a little bit interesting. It's 500 again, so let's see. So now I have the right region, but I just don't have the right permission. So that's because of my multiple functions setup. You don't have to go through this. So for now, I just kind of assume this role because I have multiple accounts. And let's try this now. If I try this, taking longer.
You did promise errors. Oh, there it goes.
So let me just actually move over here. So it makes it easier for us to kind of see what's happening quickly. So I can see, if you can see my screen, yeah. If you can read that, I can see a lot of kind of issues with Xray not having a subsegment, etc., because we're now running Xray Agent, which is fine. SAM will actually take care of that when it deploys.
Okay.
Xray Agent actually runs in the Lambda service, so we don't have to think about this.
Okay.
Because we don't really care about distributed tracing when I'm doing local development, we just ignore those errors. Now we can see that what we printed is ciphertext.blob and key ID, which is exactly what we were expecting, right? So what we need to do here is we could return just what we are interested in. Because we are super hackers, we want to see these pieces here, right?
Mm-hmm.
Because that's how we can say it's encrypted. So let's try to encrypt again. And this time we are returning only the ciphertext blob. And if we try this again, I can see that I can have all of this data in bytes. So I have two problems here. Because KMS returns as a bytes, I will not be able to actually decode this and go straight away for JSON. Mm-hmm. Because JSON will complain, wow, this \x11, etc. It's probably Greek for me. Sorry for Greeks. We need to do something else. So what we could do here is we could do base 64. Well, you could give me another idea if you need to.
Well, we're super hackers, base 96, but base 64 works for today.
Cool. Okay, so let's go and import a base 64. The good news is that it comes from a standard library, so we don't need to do anything else. So if we try to do a base 64 on this first, we could say, let me see. We could say this is the payload, right? That we're interested in. Mm-hmm. And then we can say, as a payload, we could do this, and we could just do something like this. Let's see if that works.
I think you maybe had a spelling error on your import. Just give it a quick check. Oh, no, you're fine. Sorry.
Yeah, it was just mostly on the spaces and everything. So let's see if that would work for us now. We would just return the payload as a base 64 now. So let's see how that would work. Now, it is a base 64, but still bytes. Correct me if I'm wrong, but I think JSON doesn't marshal bytes. Only strings or integers or floats.
Yeah, you got me. That's a question I'd have to look up.
Okay. So if we were to try this, right? Let's try this now. So we could do payload and see if that would work. I think that would fail, but just for the sake of it. Okay. It doesn't because it's not serializable. I don't know if anyone in the chat is actually mentioning any of these pieces, but don't worry, we're actually going to get through that. It's just actually testing the waters for now. So we need to actually decode this piece here. So we could either decode from here, which makes more sense. We could decode from there. So let's just code from here. And if we try it again, let's see. I can see that now I have a string. Mm-hmm. So now I'm safe to assume that I could take this string, marshal as a JSON, and return that back to you as from an API perspective. So let's do this. I call this encrypt, and I get all this beautiful data here. I print over here. I could now say something like this. I want you to tell me where the data is, and then I could say encrypted payload could come over here. So let's see if that works. Call again. And now we have it. So this is the basis of our encrypt API. We print something, we encrypt just there, and it just works. Of course, we're hardwiring the key in there, but we can definitely make some improvements in there.
Mm-hmm. Okay. And at the moment, you're writing everything all in one Python script. Do most customers write it this way, or do a lot of customers create modules and then just write a thin bit of Lambda function that invokes code from the module?
Mm-hmm. So there's a bit of both, actually. When you look at this structure, you will see that the Lambda function here is called still called first function. We need to rename it. And you see that this function, because it's super simple, we can have just one file that does everything. Mm-hmm. We could have a sub package or a private package that says encryption, mm-hmm. and then we could inherit from there, and then we can do something with it. Okay. Exactly the same way, we could also write everything in a single Lambda function, encrypt and decrypt. But we don't want to do this, because if I give my function permission to both encrypt and decrypt, that could be a problem. So I want to separate this. So what happens also is you may want to have for now we have a pip file for the whole project, but we could have a pip file in addition to specific libraries for a particular function. So that's something that I see customers running out there. And they also run, with pip, you can also share private packages through Git. So you can totally have a shared module instead of having a file in there. It just actually shared as a module through pip, and your shared code now becomes just a library exactly as it should be anyway.
Okay. All right. So if you're taking, say, maybe a Django application and migrating it over to Lambda functions, you probably have to pick apart very, very little. You just invoke the same functions after, decoding the context object that you receive from Lambda and then passing that over to
Yeah, the only change in there is that you don't want to run a web server to take requests from them. Because then you kind of defeats the model of simplicity in that sense. But you totally can pick up only the functions that make sense for that application and just focusing on that.
Cool.
If we actually time this, it's going to be, we just took just a few minutes to get that implementation done. And so now if we move to the next part, we get this data already there. So I'm just going to clean up the code a little bit. I don't need this preprint anymore. And I don't need this stuff here. And we also need the key to come from somewhere, right? So we could do, this is what we could do. This is something we're going to deploy that soon. In SAM, you can pass a environment variable, for instance. And normally you would say, what is my key coming? So you could create a key, everything in the same template, and then you could reference that key. Because we're using SAM local and that's not going to work, what we do is that, well, we just pass a string, which is actually going to be exactly like in production. So for now, let's see if that works. So then we can remove this piece we're not really interested in. We could do, what is my key? Let's say KMS key. We could say the environment variable is called capital key, right? So if there's no key, we could simply say, we can either raise a exception like a value error or anything like that, and we can just stop from executing right now. So for now, let's do something really basic. Let's say KMS key not found and therefore cannot proceed. Super simple. I'm using OS, so I need to import it as well. But as you can see, most of it is actually coming from the standard library. I'm not bloating anything with that sense.
Now, shouldn't the KMS key, because you're doing an OS getenv, shouldn't that be initialized in the global space rather than in the Lambda specific handler itself? I mean, once it's initialized, right? It's not going to change over the course.
Actually, that's a really good question. Let's actually put that outside. So by the way, there's actually there's a pros and cons to that though for environment variables for people that they should know, because this is a build on serverless. One is anything outside the handler will be executed only once. So we can cache a lot of these things in here. Soft states like TCP handshakes, SDK initialization, connection pool, for instance, all of these pieces, we can do this. So if our function is being invoked multiple times, we can reuse that. But for environment variable, if we ever need to change something in there very quickly, we may want to have that inside the handler.
Okay.
But because every time you deploy that or make a change, that will trigger a new change for the whole environment, so it doesn't really gain too much.
Okay.
So you're totally right. Let's actually go from here, add the KMS key, and then everything else should be able to access that thing. So let's actually do this, and let's try that one more time, and then we can crack on. Oh, here we go. What is it now? He's actually saying if... Is that because I missed global? So it's saying that there's no KMS key in there. Is anyone in the chat that can help us with that? So KMS key, maybe what's missing is the global. Let's try that again.
Before writing back to it.
Yeah, so let's see. So yeah, still complaining though.
KMS key.
If we try to, we could totally enable debugger here, but for now, let's just do something super simple. Let's try. Oh, I see what that is. So if anyone in the chat knows the answer, feel free to type in. Otherwise, I would tell you how silly the mistake was.
Real quick, VS Code theme. the important stuff.
So is anyone asking about the VS Code? I don't know exactly what you want to know, but what I usually do is I use something called Dracula as a... That
was a guess, yeah.
Yeah, a Dracula as a theme. And I also use Material as an icon theme as well.
Okay.
And from here, I just add a bunch of other stuff like Pandoc, PyLent, and ZSH, Flake. There's a lot of other stuff in there. If you want, totally comfortable, ping me on Twitter. Happy to sync that up to a GitHub or a Gist. There's nothing confidential in there. And of course, because I used Sublime for such a long time, I prefer the mappings from Sublime.
It's all right. Won't hold that against you. So, global KMS key. Why is it not finding... You know what? Should we just make it simple? Put the KMS key definition in the function itself for now. We've mentioned about best practice being initialization of DB pool connections and other things in the global initialization space. Yeah, for today's purposes, should we just do an OS environment in the function itself?
So that's not going to work. So that's not yet where the problem is.
Okay.
So if no one on the chat knows where the problem is, I will show you how to troubleshoot that. No one.
Nothing coming through yet.
We don't need the global for now. What we're doing here is that when we do have hot reloading, because every change we make, we can see it's working. However, when we change the template, some local loads that into memory. So we need to restart some local so it can read from the new template. So what we just did was we changed the variable to key. And the reason why is actually saying if not available, well, it's just because there isn't any environment variable like that.
So SAM local is reloading the code in a hot way, but it's not reloading the configuration of SAM local in a hot way.
Exactly.
Okay.
So this will be the first kind of a lesson learned from today. If we try and make run again, hopefully I don't make a fool of myself now. If we try that now, here we go. You see that works now.
Much better.
Perfect. So, okay, we got all this and we got that working. So we got the encrypt and we got all this. Let's actually make this deployable. So, and then we can see Xray, we can see all these cool features for now. So this is like getting started type of thing, like testing the waters. And we go as deep as actually having even a canary release today. So just double check if I'm not making any silly mistake. We encrypted data, we encode as a base 64, decode the byte so we can make as a string, and then we can go from there. I don't know how many people actually, I think I just got a message on my phone now. I just realized that there's a new people actually joining the stream and they probably don't know what we're doing.
Okay.
So I'm just gonna, this is the type of agenda we're trying to look into now. What we just done is we explain what Serverless Application Repository is a service that allows you to consume and publish serverless applications for anyone to consume privately or publicly. We explained about SAM, Serverless Application Repository, very quickly, where that lives, and a bunch of examples. I showed you something we published today called Cookie Cutter, which is an open source tool that was built by someone else, not us, and allows you to template anything you want. So it creates a scaffolding. Think about Yeoman for Node.js. And then we walked through about the SAM template, the structure. We also installed all dependencies, used some local to do a bit of a testing there. And we did our first code in there using encryption in that sense. We haven't got unit testing yet, but hold there. So let's deploy this. So at least we can do something. So here's what we need. If I just kind of stop this right now, what we need here is we need a function. We're going to change this to encrypt. I'm actually change this completely. Encrypt function, because I don't want to call first. It's just not helping me. And I want to change this to encrypt. So now I have a folder called encrypt. It makes a lot more sense if I were to do a git. I still get everything from build, which is fine. Everything works there. And I'm calling encrypt. I could change to post, but let's leave it there for now. And I don't like this. We want to get rid of this. And we don't have any additional permissions to be made, but this is something we're going to use because it's useful. And of course, we output the API gateway URL after we deploy this. So what we need now is we need to create a KMS key programmatically.
Okay. And just real quick before you move on, Heitor, if you scroll up a little bit in terms of the function definition, where we have the handler specified, we're specifying app, which is the name of the file, dot, and then the name of the function that we want to have Sam invoke. Yeah?
Absolutely right. Okay. So when you look at the code URI, if I try to highlight this, you see that the encrypt is where my function is, and /build is where my files are. And from the encrypt, I could say that actually inside the build, I want to look at the app.py, and inside the app.py, I wanna tell Lambda, how do I invoke this function? Where do I pass the invoked, the event and the context? So in that sense, it's actually here. If we were to change something like just Lambda or something else, that would just also reflect the template.
Okay.
So because creating a KMS key, it is actually quite big. And even if I go to the docs, it may take me 10 minutes to go to all the parameters and explain all of this. So what we're going to do now, we're going to cheat a bit. Remember when I told you that what we are building right now is already available as an open source, and we already encrypt and decrypt and everything. Inside this template, I already have my KMS key. You can see how long that is already. So I'm going to show you one more trick in SAM, which Sanaf and a bunch of Jacob and a bunch of other folks updated the docs recently to make this available for you. What we need is, if we actually copy and paste this, I can see it's aligned, and now I can change this to this. And this, if you're the first time you're using CloudFormation, if I were to look at the type, I want to see if I copy and paste this into my browser, I will find a documentation explaining exactly how I should build. The important piece here is the return values for us. If we click on return values, that tells us that if we return as is, we should get the KMS key instead of an ARN, which is exactly what we want, right? So I'm just gonna stop right here. And now this is the tricky piece. If you look at the KMS key, etc., what we said since the beginning is that we want a function to encrypt and one function to decrypt. And that means in the key definition, we can specify that only allow KMS encrypt for the encryption function, and is the IAM role that we need to know. The problem here is that when you look at SAM, you are not seeing any IAM role in here. It's being created implicitly to make it so much easier for you to run serverless applications. So what I added here as an example is that SAM actually gives you the documentation to explain where exactly you can find those pieces. So how would I go to find that information? If I go to SAM, the docs, and if I click over here, this is the whole GitHub repository, by the way. So if you click on the docs, there's something called internals. And inside internals, there's something called generated resources, which is every resource that SAM will transform to CloudFormation so we can deploy. So we want to find out, how do we know the role that this function is being created? So if I open up this, you find lots of this piece in here, right? If I click in function, you will see that a role is nothing else but whatever the name we defined plus role. So what we can do here is we defined encrypt function. If we go back in here, hopefully you're staying with me, we just need to do this. Okay. And from there, we will be able to get the role for the encrypt, and it should be able to just work.
Okay.
And for now, we don't have an encrypt function, but let's just actually leave as that for now. Then we can try to make a change or something afterwards. So we got all this. I don't need this property. I don't need this permission. We are actually ready to go. We're ready to deploy it, and let's see if that works for us.
Excellent.
So if we go to the README file that I prepared for you, you will see everything you need for deploying. It's actually not only all the commands over here, the AWS CLI package, deploy, and describe, everything is already there for you. So I'm going to change this to one of my buckets. So if I just go over here, because I never remember the name of my bucket, it's quite big. If I replace this with my bucket name, like I said, I have multiple AWS accounts. You don't need to do this. So I will just use the profile demo, and we don't have any parameters as well. So we can just scrap this and say profile demo as well. So let's give that a go, and let's see if that works. Then I'll explain to you what that actually does. And if deployed, then we should be able to start seeing some interesting stuff from Xray, and we should also be able to start seeing some stuff from deployment perspective. Actually, I just forgot this. If we were to deploy this right now, we may be able to see a deployment that's going to take us a long time for us to do it. For now, I'm just going to do it, and then we're going to change this to something much quicker. If I deploy this now, if you notice the stack name, it was actually the input from the cookie cutter. So if I go and deploy this right now, we should just wait, it creates everything. And one thing that if you notice is that after I run this command package, I had to specify an output template file. If I open up that file, you will see that in the meantime it deploys, of course, you will see that it looks almost the same SAM that we had it. The difference here is that we now, remember the code URI, where it was supposed to be encrypt/build/something. What that package does for us is that it packages everything as a zip file, and it ships to S3, so then we can deploy it.
Okay, so it's taking your Lambda function, rolling it up into a zip file with all of its dependencies, putting it into S3, and then deploying a CloudFormation template derived from the SAM template. The SAM is kind of a CloudFormation shorthand.
Yeah.
And then pushing the CloudFormation template into CloudFormation, which is going to reference that Lambda function, the zip file, the deployment package in S3.
Exactly. Okay. And if we want to do CI/CD, for instance, we could say that this is going to be our packaging step. We install the dependencies and then do a packaging afterwards. And this will be a separate step just to deploy. So then we can separate the packaging only has permissions to upload the artifact, nothing else. And the deployment has permissions to do a lot more stuff. Okay. So if we fail doing the tasks, doing anything else, then we don't even waste the deployment in that sense. So let's see. It's almost ready. If we go up on our AWS console now, you will see in CloudFormation, we have a new stack called, let's say, crypto here. You have a new stack, in fact, just finished creating. We have a new stack created called Simple Crypto Service, which was our deploy. And if we click in resources, you see everything we defined and much more. We also see everything that happened, what resources were created, one after the other, their dependencies and everything.
Okay. And in the SAM template, you defined a function and a key.
Yeah, that's right.
Two things which resulted in all of that.
Exactly. So when you create a function and you want to know who's going to trigger that, you need the permissions from API Gateway to trigger that function. And you also need IAM roles for your function and all that stuff. All of this have been abstracted from us.
Wow, Sam's really doing a lot of work for us.
Absolutely. Thanks enough. Thanks everyone from the SAM team.
Yeah, absolutely.
If we go to the outputs, remember that I was telling you that the API gateway should be in there, except that I forgot to change the right API. Remember that we added as a encrypt and not as a first. So this should actually be encrypt URL, not first function, and this should be encrypt. If I were to try to copy this now, this would fail. So this was a mistake on my end. If I were to do /encrypt now, let's see if that works. Here we go. The reason why that works is, remember that in our code, in our Lambda function, we actually now get the key from the environment variable. We no longer have to hard code anything. And from the template, we actually create the whole key over here inside the same template, and we reference the value so that our function can take that and it can encrypt just fine. The cool thing is that if you haven't noticed, like the issue is that for now we are just encrypting some hello data. We're not encrypting any data that we send, so we need to change this. So one cool thing about it is that before we go for this is that we enabled something called Xray. Remember that?
Yeah,
the way we enable this, we imported the library, we patched everything, and inside my SAM template, I actually had something called tracing. That is what you need to enable distributed tracing. Let's have a look and see how that reflects now. If I were to go again to my services and look for Xray, I will see that hopefully I have enough permissions and I have all of this already figured out by SAM. And here we go. Wait. Yeah, it works.
There we go.
So now you can see that the function that we executed through the console, even if we didn't pass any data or something and invoking some basic string to be encrypted, we can see exactly what happened there through the encryption. So what happened here is, if it is the first time we're seeing distributed tracing ever, we are seeing that this first circle is Lambda as a service. So that means we need to bootstrap the whole runtime environment. We need to do something with that function first. And we get the zip file from S3, what we just discussed. Next, this is the function. This is our function. This is how fast our function runs. In our case, the average is about 65 milliseconds. Because we are talking to KMS, we actually need to do an encrypt, and we also need to do TCP handshakes and all that stuff, which is super cool. If I click in there, I can even see that the first time I executed, this was a code invocation or a cold start. We didn't have a runtime environment. We had nothing. So we need to download the code for the first time, bootstrap everything. Next time I run it, it becomes so much faster. So if I have consistent load, that wouldn't be a problem in that situation. If I click in view traces, what we get as information is we have a lot of traces in here. We get a response time and we get a lot of these pieces. Before anyone asks about cold start, I just want to show you how a cold start looks like from here, so you can get a little bit more advanced information from this session. If I try to sort this by something really slow, like 1.4 seconds, I would click in here in the trace. Here's what I know let me see how big this is. I know that this was a cold start, the first invocation, because inside my function there, you could see there was something called initialization. So this is the time that the Lambda service took to create everything for me and download the code, etc. And this is the time that it took for my Python runtime to bootstrap everything, to import those libraries, scaffold, do the initialization from the global scope and everything from there. This is why you actually mentioned me as an advice. If we add that stuff that takes time from the outer global scope, next time you execute, we already have all that already cached. So that's actually much faster in that sense. What's also cool is that we can have all the KMS key information from here. We can also see the encrypt API call, how long that encrypt actually took. If we were to select anything in here, let's say initialization, we get the start time, we get IDs, we also get what is the Lambda function that was actually meant to be invoked, the ARN, and everything else. If there was any issue, we would show exceptions, etc., etc., etc. So that becomes quite useful, especially when you're dealing with something in production. You want to know exactly, for instance, what is the request ID that my Lambda function received as a return when I call KMS encrypt. So they can get all that from Xray and just move on from there.
Okay. Now, if I needed to get in touch with, say, support, I see some sort of anomalous issue that I really can't explain, that I'm getting a lot of great information about from Xray, but still I don't understand it. Is it the request ID that I need to reference when I talk to support, or how do I help them to help me?
Sure, absolutely. The first thing ever is request ID.
Okay.
Without request ID, they can't really do much. They can't really get into your account and try to find every call that you made. Even if they could, it would be just impossible because there are just too many calls.
Okay.
With the request ID, they can find out what the caller was, who the callee was in that sense, which language they use, in this case, Barto SDK for Python. They can see a lot more. If you had an exception, what was the exception? Copy from here. What was that we were trying to do? We were trying to encrypt data. It was a key that you own. It's a separate account, cross account. Trying to detail the business case. Okay. So that makes so much easier for people in support.
Cool.
Okay, so from here, what we can do is, we already deployed all this. We can do two things. We can try to fix our function now to receive through the API some data, right? So we can want to send some data that we want to see being encrypted. We don't want to simply encrypt hello, right? If we go back in here, what we will need to do is we need to take that data from event. Remember when we were running some local, we could see generate API, and we were able to see, if that's not big enough, let me know, what API gateway will actually send to us. What we need here is we need access to the body. And then by the body, we need to make as a JSON so we can look up and do something with it. So from an interface perspective, because I return just the data, I would expect the data as an input as well. So I could do something like this. If the key is not there, we create an exception. Of course, we could do just a 400 or something more, better for user interface. But for now, that's it. So I need to get the data first, right? So if I do this, I will not be able to get access to the data, something like this, because it's not JSON, right? So I would just do something like this. And see if that works. And if that works, then we would be able to show that this should actually be data, right? Okay. So let's try this locally first to see if that works. So remember that in the template, we now have this. So we need to copy this for now very quickly. And we just, because some local can't understand that particular resource, and there's no way as well to do it. So we're just going to go back to our CloudFormation. Now we're going to use the key that we actually really created. So if we go to resources and we see KMS key, that's the key we want. Actually, sorry, that's not going to work either because it only allows my function to encrypt. So let's actually use the old key. So where was my old key? It was actually over here. If none of that makes sense, please let us know. We're actually here to help you as well. So we got the key and we're going to change this back, of course. And if I were to run that again, let me go back to my local, some local, and see if that would work. I think that's not going to work. I just remember now because we're saying data and the data will have a data. This is where you were supposed to have it.
Fantastic.
So let's try this make run now and see if that would work. And now we're going to use a proper actually API client because now I need to make a post and make it more visible to you. So if we were to do this now, we would copy this and we would send a post including data inside. Hang on, I haven't even sent a message. So I'm going to say super secret. And let's see if that works. Works. So that means I can send data now and I can send anything I want. And I can even do some load testing now with post data and test anything I want. Because that works, we're actually more than happy to try that out. We could go back in here. We could remove this, go back where it was. Let me check if there was anything I missed. No, I can set the data of the data, encrypts the data as it should. And we essentially do exactly what we did before. We would actually just package this up and deploy and do everything else. Okay. There's one gotcha though. We haven't explained to you this. If I were to deploy that now, this would create a canary release for me. So that is good because it shows you how that would work, but also it would be bad because we have still more information to show you. What I would want to do, I would still want to do some canary linear deployment, but instead of extending only 10% every 1 minute, because that take a long time, we want to change this to something else. So here's how we get more information. There's a comment in here with the link to the documentation, and let us explain to you what this means. SAM integrates with a service called Code Deploy that manages all the deployment for us. Rollback, shifting traffic, or anything like that. So we want to use this technique to actually do exactly the same for our Lambdas. So if we go over here, you see exactly what we have in our SAM, but we want to do something faster. There's got to be something in here. If we keep scrolling, you will find a big example on how we could do exactly what we're doing. if we keep scrolling, this is what we're looking for. We want to know what other configurations we could potentially use, and then we could just, just use that from there.
Okay.
So for now, what I want to do is I want to just run a canary actually, just for 5 minutes. I don't want to keep sending 10% of the traffic. I just want to send there and see if that would work. So we go over here because as far as I know, we can only send every 1 minute, and that's going to take time. So I want to only spend 5 minutes here. And if that's working, that means I should just throw back everything to production afterwards. So if we go ahead and try to do that again, here's something super interesting you should know. We package this up and deploy exactly what we just did. Because we changed the code, SAM will do a hash, and if we haven't changed the code, it will just not make any deployment in that case. Unless there was some configuration, but not the code itself. So now we just wait for a time. Now, rather than waiting a couple of minutes until we see all this, I want to see how the canary release is actually working. If I go to my CloudFormation now, and I just refresh this page, you will see that now it is in update in progress. But what's interesting here is there's something called AWS Lambda alias, which we haven't explained as well. In the meantime, that creates, every time we make a deployment to a Lambda function using SAM, we can specify, don't send everything to the latest version, but actually create an alias called live, send a percentage of the traffic to this alias. Once you're comfortable with, then put everything else somewhere. We also have something called weighted alias. You can have an alias that can send 10% of the traffic to the alias dev and 80% to prod and 10% to, let's say, canary.
Okay, so I've got multiple versions of the same Lambda function defined within the system, and then I can kind of create a soft link in the form of an alias to those versions.
That's a great, yeah, absolutely.
Okay.
So in the meantime that's being created, I will show you 2 things. I want to show you code deploy console, and I want to show you in Lambda what we just described. If I go to Lambda now and look up for crypto, you will see that I have a minute ago I just deployed. This is the Lambda console, everything. If I click in qualifiers, I can see that I have more than one version because we published multiple times. And you see that we're not using latest, we're actually using live.
Okay.
And because we're running Canary, this live, once complete, should go to the version number 2. If I go now and I try to make a call.
So I could have a production alias, a beta alias, an alpha alias, as
Exactly
many
like
as I
this.
want, right?
Exactly. If I try to make a call now to my new function now that accepts the data, if I try now, it may work. Maybe it's already past 5 minutes. But ideally, because it's actually taking its time, 5 minutes, it might fail for that, or after a while. Okay, it's still working. If I go to code deploy, I will see that I should have a simple crypto service over here that was created today, April 10. If I click in here, I see that the deployment is still in progress, right? If I click here and change to deployments, what you see here is something beautiful. You see that 90% of the traffic is supposed to go to the original version, but I would probably need to hit a lot more APIs to go to that particular version. And you also see that 10% of the traffic is being shifted to the new version. But when you go to the Lambda console, you don't see that, right? This is handled completely by code deploy, and all we did were 2 lines. And that was already added by cookie cutter. So essentially you did 0 to actually get a canary release type of deployment to make sure only percentage of the traffic will go to the new version.
Okay.
What is even cooler than that, at the bottom, if I were to zoom in, you see before allowed traffic, after allowed traffic, and all that stuff. I can essentially go here and do something like this. If I were even more adventurous today, which I'm not, I could say pre-hook Lambda, and then in here I could say post-hook Lambda. Actually, in this case would be because of semantics. What this means is that I want code deploy to invoke a function that I create before I open up any traffic, 5%, whatever that means, maybe I could use this for validating deployments.
Okay.
After the send traffic, I want to run another function to do a deep validation of my deployment. So we could use, you can help me out. We could use pre-hook for database migrations, or notifying someone that there's some traffic in there, or changing notification on, say, a Slack notification. And in the post, we could do something similar. We could just run a smoke test or something more complete.
Now, what about the return value of those Lambda functions for the hooks? I mean, is there a way to say, no, hold on, I've checked something and it doesn't look quite right. Don't go forward with the deployment?
Absolutely. We have in there examples, actually. If we go back to this Serverless Application Model repository, if we go to, forget about docs for now, you go to examples, there's something called Lambda Safe Deployment. Thank you, Georgie, for watching this. Thank you for contributing. If you click in template.yaml, you will actually see this in practice. You will see let me just zoom this up. You will see deployment preference, you see the type, and you also see as a hook, I have a pre-traffic to a pre-hook. When you get in here is a function. So I was wrong, actually. It wasn't even get at. It was actually a ref. I will see that this is a function that we are deploying. And the only thing that the function needs to have as an access is to send put lifecycle event hook execution status. So the function needs to return say, hey, not good to go. Okay. Fail, roll back. But what does it look like? If we open up in the source, there's pre-traffic hook JS. If we get in there, it's a JavaScript. Don't use JavaScript, use Python. Kidding. What you see here is as an event, you receive all the information you need to know about the deployment. Yeah. So what we do here is we get the deployment ID, we get the lifecycle execution ID, so we need to send something back as a callback. And what we send is what is the deployment, what is the hook, and whether we are okay with that. So we can totally fail this and do anything we want. Okay. Excellent. In essence, we can do anything we want within 5 minutes, as long as we tell code deploy and say, hey, yeah, good to go, and continue opening traffic, or we can fail and roll back as well. Okay, excellent. What's even cooler than that, because we're going to give as many tips as we can, is apart from hooks, you can also specify a bunch of CloudWatch alarms that you can say, if any of these alarms that I created in my account, programmatically or not, breach, roll back, regardless of what the pre-hook or post-hook actually told me so. Okay, so if we start to see a lot of 500 errors or something along those lines, we can automatically roll back as a response. Absolutely. So that is exactly how, let's say, bulky or complex it can be. But all of these lines, if you think about it, if you're thinking about Docker or other technologies you could use, we only use just a few lines, really, to get all of this functionality, all of these best practices in less than 1 hour. That normally would take us it took me months to learn all of these pieces. And now in SAM, we just have this bunch of lines. Okay. If we go back in now in the code deploy, because it was only 5 minutes, we can see that worked. And if we were to be more courageous and say, okay, let's see if that really works as a linear deployment, we could go back in here and say, actually, in fact, I want to send now 10% of the traffic every minute. So if you try really hard, we should be able to see the new version there. And then we can prove as well that actually, in fact, works. So before we change anything in the code, let's see if there's anything I missed or anything I should be covering. We have still a bunch of other stuff in here. We covered Xray a little bit. We cover code deploy now. We're going to cover now the linear deployments. And before we make a deployment, I want to show an advanced feature of Xray called custom segments and also an annotation to show how easy it is to do something that much more complex from a tracing perspective. And then we can finish up by actually bringing a front end and let's see how that would look like. Cool. Okay, so if we go now to our application and I think we're not going to have enough time for doing the decrypt because I'm looking at the clock right now, but I want to make sure you get the most of it and the best practices in general. So for now, we don't know much how long this encrypt as a function actually takes for us. We know the KMS.encrypt. If we want to know exactly how long that encrypt takes, we can use a wrapper. Remember when we commented this?
Yeah.
We can use something called Xray recorder capture. So we can say something like this. So this is my encrypt logic. We don't need this hash, but I find cute. So we could do this. And one thing that's also very powerful is this will only show to me how long is actually taking on that one. Mm-hmm. But what if you could sort all the traces based on encrypt operation? Mm-hmm. We could use that for database query latency. We could use that for a bunch of other stuff. So this is called annotations. So what we need to do from an annotation perspective is this. We need to capture what is our current sub-segment. So what happens as a segment is Lambda as a service, web service, creates the root segment. And then the function is actually, it creates a sub-segment. And therefore, if you want to create more, you can keep creating that over and over and over. So you can see exactly how that will look like afterwards. So if we do something like operation, in this case, is encryption, because we can also have one for decryption. If we change this now, because we want to deploy this now again, I want to show you two features. I want to show you this, and I also want to show you the linear deployment now, which is very different from the canary. Okay, so in the meantime, that's actually being deployed. It's going to take some time. If we go to CloudFormation, you see something new. In the events, actually resources, you will see also stopped in updating progress for Lambda alias. If we go to code deploy again, look at deployments, we see we have a new deployment happening now. The difference is now we're going to start seeing 10% of the traffic to the new version every 1 minute.
Okay, and what code deploy is manipulating here is the API gateway and how it's going to distribute traffic amongst the Lambda functions?
Yeah, okay. Absolutely. I was supposed to actually add a new version as a key here, so I totally forgot. So I guess we're just going to run as there, and then let's see. If we actually try to make a bunch of actually other calls, that would just work because, well, we're not seeing anything in here. So my bad. I was supposed to add a version so you could see when you are hitting a new version. So if we try to hit a bunch of other times here, just in case, what we see here is in Xray, if we hopefully got to the new version, we should be able to see, let's actually go this for the last 1 minute. I want to close this, I want to refresh this. And if I click in here, hopefully that's enough time. If we hit the no one, you can see there's a new spike in here because there's a new deployment. If you click in here, we still don't have that information, but hopefully it's going to come that recently, soon. So let's just actually give some time and then probably do a bunch of other APIs as well. What we should know, we should be able to see the encrypt and a bunch more information in here that should help us identify how long it's taking the encrypt. And that also means we could wrap the whole Lambda. We could say, how long is my entire Lambda running? How long is my import is taking? So that helps for troubleshooting as well.
Now, how does that work? So if we start to put annotations into our code for integration with Xray, how does that work when we're doing something like SAM local where Xray doesn't live?
Okay. What happens in this case is that you will simply just ignore.
Just gets ignored.
What happens is that you will first ignore because there's no agent to send that information to. Mm-hmm. So in that sense, you would simply say, well, I don't have any agent. Anything else, just black hole this.
Okay.
Because it's going there now, if I go back to code deploy, I can see it's already in 30%. So hopefully if I refresh again, refresh the whole piece just in case I have something cached. If I go back in here, hopefully I might have hit the new code already enough times. Yes. You see that in the group URL we have something new called annotation operation. Mm-hmm. If I click in any of this, hopefully already, here we go. I have annotations. If I click in one of those, I can click in here. Remember this? now I can see, and I can also do this top down. I can see, first I run the encryption logic. Now I did send traces to somewhere else. Now I also send that. So that helps a lot when you're trying to understand the performance or the profiling on that piece. What's even better, and that is something free, which is something I would encourage you to do. It's a more advanced. If you go back to traces now, and if I click in annotation operation, the only operation that I have is encryption, which I actually did here. If I click here, I would see all the traces that actually, all the code that run after this. So I could get all the traces and I could see exactly what is the average response for all those encrypted operations. What is the average for all the decryption? What is the average for making an API to a third-party API? So you can use this feature to automatically allow Xray to index all those features, all those responses in a much nicer way.
Okay, excellent.
So if I were to click again, that's fine. There's nothing else in here. It just works as I was supposed to do. Let's see what else we have left. So I got this over. I don't need this anymore. So the one that we were supposed to do was cores, unless someone actually is looking for something in the chat. I don't think so. So it's 50-50 now. So I would just leave it there for now.
Yeah, I mean, I think that the next step here, so we've built an API gateway. It has Lambda, which has all of our application logic on the back end. And, you know, the next step, of course, is how to secure that beyond just TLS, right? So how would you have an application talk to your API gateway and do that in a secure fashion? How do you authenticate users? What's the way to do that?
Sure. We're not going to do that today just because of time. And because we also have upcoming episodes that one of them will always only talk about authentication and every authentication and authorization option you have.
Okay.
Perhaps we can even reschedule this for another day, and then we can just continue from here and just do authorization. But let me show you what you can do today. If I go to API Gateway console, I should have a bunch of APIs here. Don't worry. We are interested in a simple crypto service. We're not going to do it through SAM. I'm just going to show you. When you select the method, which is supposed to be post, I click method request because I have it changed, of course, and I have authorization. From here, I only see one option, which is AWS IAM, so you need to do SIG-v4. So you will need to get access keys, secret keys, sign, hash, and then send that through API Gateway. Of course, to a user, that's too complicated. We want to do something much simpler than that. So what we could do is, if we click in authorizers, we could create a new authorizer. We could use something called Cognito, for instance. And from here, I can select a Cognito user pool, which means all the user management, all my users, authentication, authorization is going to be managed by Cognito.
Okay.
And then from here, I can say, when I send the token, so my OpenID token, it has to be inside the authorization header on my HTTP request. So I could do this. And I could also create a new authorizer, which is going to be a Lambda. Normally, we call this custom authorizer. So that means I could have any function developing the same way that will tell API Gateway whether to authorize a request or not.
Okay.
So that's how flexible we can go from here.
All right. And then from the JavaScript and say a web application, I can use the AWS APIs or just, as you said, create, I think Requester is the name of the JavaScript library for, or no, I'm thinking of Python, sorry.
Yeah, no, we have a bunch. We also have AWS Amplify, which is actually a library that does all the heavy lifting for you for the mobile authorization. But it's not the scope for today.
Okay. But in a single page web application, you could communicate with that API using the same level of security that's wrapped around the AWS API itself.
Absolutely. If you want to get down that path for now for a single application, this is what I would recommend. There's a library called AWS-Amplify that allows you to build mobile apps and also web apps in the sense that it facilitates the needs of creating all of this authentication piece, connecting to S3, creating a UI for authentication process for Cognito. As you can see, it's actually using React. Also, what we just described about signing HTTP requests. What if I want to use Sigv4 because I wanted something stronger? So all of this is actually being handled by Amplify.
Okay, cool.
So that's where I would start. There's some demo codes in here as well if you want to get along. But yeah.
All right.
So that will be a sneaky peek of what's coming on the authentication episode. What we promised to do was to actually have a front end to call this API. But we're gonna have two things. First, I'm not gonna show you the code for the front end for now, but I will show you that you need CORS because we're gonna run this from a local laptop to an API. So one common question is, how do I do CORS in Lambda? Today you're gonna learn. We're gonna go through the docs and we're gonna show you exactly how I would do. So let's see if the code deploy is finished. Almost there. So just because I'm stubborn, I want to do this. I want to make sure that I have a version and I can call something else. Let's say 2.0. The next time I make those requests, I want to see that version. So you can see exactly what I mean by that. So how do we do CORS? So first, CORS has two approaches, right? One is called pre-flight, which is a HTTP options that the browser sends to whatever endpoint you have. In this case, it's API gateway. And you also have the backend CORS, which we need to implement that in the Lambda function, right? So just to give an example how that would fail for now if we were to try. I'm sure I have this over here. I have a front end here that I built using Vue.js, not React. Just for the setting fire in the conversation. What this does for me is if I go to my components, I have an encrypt and I have encrypt and decrypt. What this does for me is all it does is a HTTP post to the API gateway and it sends the data in exactly the format that we already did.
Okay.
So I would have to replace this now with my CloudFormation. If I click in outputs, I would see the API over here, which by the way, now it's updated to encrypt. We were to do something like this, because it has hot room reloading, I already have that information. So I think it's a localhost 8080, let me see. Yeah, something like that. Of course, because I am a designer, you can see how beautiful that is. And if we try to type something to encrypt, let's say, as a Brazilian laughing on the internet, you will see that it fails. If you click in show output, well, it doesn't tell much, right? It tells that, well, the endpoint I was trying to send a request to and the data I send, which is exactly how I would send through my Insomnia API client. If I try to open up my Chrome developer tools, I would see this. I would see that the response from this API doesn't pass the control check for the pre-flight request, which means API gateway doesn't have an options set in the API gateway definition. So we need to do this.
Okay.
And he also says that there's no access control, allow oranging, all that stuff. So how do we do this? We go to the documentation again because it's our friends. If we go back to versions, we click in the version number. At the bottom of it, if you scroll down, you see there's a CORS configuration in here. So what that means, we need to add this into our global definition. And if we were to do this, we would do something like this. Oh yeah, by the way, because I keep switching very fast, under examples, we also have an example for CORS. You will see that over here. So that's exactly what we're going to do. So let's go back to there.
So for people who are just joining in, we've got examples in the Serverless Application Model repo on GitHub. And then there's also the Serverless Application Repository, which is a whole separate entity hosted by AWS that hosts a number of different serverless applications that people can reference as examples or even deploy and test for themselves. Absolutely.
So for now, we are simply adding CORS into our API. And of course, because I have a bad indentation that would fail during the packaging, so we want to avoid this. So we want to say that we only allow post and options. So for that, we're also going to change here we only allow post, but then API gateway will do the pre-flight. And what is the headers we wanna accept? Because my Vue.js actually sends a content type from JSON, we want to allow for this, but that means you can also add any custom header. So we finish this, and then the allow oranging. What is the oranging of my application? Well, if we go back in here, it is localhost http.8080, all right? So we want to do this. We don't want the slash because otherwise it fails.
Okay.
And then we don't want the max age. We don't care about this. So this is how we would implement that. So let's see how that would work. If I were to go over here now, let me see if I'm missing anything else. We have the API encrypt, we have the post, we have the KMS key, and all that stuff. Let's deploy this now. If we deploy this, we should see inside our API gateway a new options definition.
Okay.
And we should be able to see the same headers we just defined. And that means our pre-flight will work. But actually, because I forgot, I was supposed to write the cores in the Lambda function as well.
Okay.
So that's going to take us some time. How do I do this? My bad. So because it's quite tedious to write this, I just wrote a snippet for me. Right? So we just need those headers over here. So we're gonna do this. We wanna allow 8080. We wanna add content type, and we wanna add only options and this. So we don't need this. Okay. So now this is how it's supposed to work, right? So apologies, we're just gonna do that again. This is what happens in live coding. You're gonna do everything from scratch, and you're gonna miss something. In the meantime, that deploys, it's just not gonna allow me for the next 10 minutes. So we can talk about other things. So let's see if that already made the change to my API. If I go to API Gateway now, and I refresh all this, I don't care about authorizers right now. We can do something afterwards. If I click in resources, I still don't get that. So it's still gonna take me some time. I should be able to see options over here.
Okay.
This is exactly the same way as doing actions, enable cores, and doing something.
Okay.
So we're just gonna actually have to wait. Just for the fun of it, just before, if we try actually do this now I have version 2. If we hit a bunch of other times, we don't see it. So now I can prove that the deployment actually is working right now.
So there's a question about a 10-minute build. So the 10-minute time that Heitor was referring to just then was a staged rollout of the latest Lambda function and the configuration changes that have just been made. So it's going to, over that 10-minute period, shape the traffic, right? That is distributing across. So that's the reason for the cores taking a little while to take effect.
Absolutely. So if we go to the template, just to clear that out, inside my globals, where I can define properties for all my functions or all my APIs at once, I have a deployment preference that says send 10% of the traffic every 1 minute. So that's why it's taking that. And the deployment is actually stuck in that update in progress until code deploy say, hey, I finished. And equally, if you were to define alarms or anything like this, it would roll back whatever the percentage that is.
It's also worth mentioning too, Heitor, that if you're talking about in a development account and in a development environment, when you're in the heat of building things, you're not going to wait 10 minutes. You're not worried about canaries or A/B testing. You just want to get the thing deployed, do a functional test. So probably your SAM template that you push to the development account or the test account is going to be different than the one you use for production.
Totally agree. So in that scenario, which you still want to have an alias close to production, what you do here is if you go to the docs again, and we go to Lambda Safe Deployments, where I added into the cookie cutter, you'll see the traffic shifting configurations also allows you to have all at once.
Yeah.
So you can have a parameter that says something like this. You can have a parameters inside your, let's say, deployment preference. That could be the value, and that could be, I don't know. By default, it will be all at once. And then you can have this, something like this. So that means you can have even an if condition that says, if I'm running this into a pre-prod or production or something, I probably want to send more traffic in a faster linear time. Or when it comes to production, I want to set this lowest or a canary or something.
Okay.
So I can totally be in control of whatever I want to do.
So then from the command line, from your local development machine, when you issue a make test versus a make deploy or a make build, you're probably going to be pushing to a different AWS account with different set of parameters versus pushing to production, which actually ideally should be done by a build server rather than from the
absolutely, yeah. We because we're gonna run out of time because we spend more time explaining some of those pieces. We promise we're gonna do another one to extend this and cover authorization and cover the CI/CD as well. But the CI/CD in a real world, it would look something like this. We also have a new blog post about this. I will show you in a minute. In a graphical terms, this is how it should look like. You would have a pipeline that would have the code in a dev account, and then the pipeline would build the artifact, install the dependencies, and deploy in multiple accounts. Whatever the account you use, you can still define the deployment preferences and everything as well.
Okay. So the internet is demanding that we not wait 10 minutes. Can you swap out for the all at once and just redeploy?
Yeah. Let me just go back in here and say all at once. If I cancel that, I could have some. Maybe I could have some
unexpected behavior.
Yeah, I don't feel comfortable with that. So it's actually just finished, or maybe there's another one here. So let's say it's 60%. So just 4 more minutes. Apologies. We're gonna do this. Let's actually get ready for another deployment just in case, right? Just gonna copy all this, and I just want to run another shell. And I don't want to deploy this now. That's where you helped me on that. Preventing me from making disasters. So I just want to package that up to the new code. And now we should have, all at once, we should also have cores. And inside my application, we have cores exactly as we are supposed to. So 70% almost there. So I'm just going to hold my fat finger and not deploy.
Now, in order to enable cores, if I've got, let's say, the pet shop example that you can deploy through the console, just as an example, API gateway deployment backed by Lambda, do I need to put cores, the response, into my Lambda function, or is it enough just to tell API gateway to enable cores and it will craft the response for me?
Okay, so that goes back to the point where we said cores is divided into 2. One is a pre-flight option that the browser will send, so that's handled by API gateway. Because we are using something called proxy integration, where we send everything as is to Lambda, and whatever Lambda returns to us, we return to the user. That's why the interface definition over here about status codes and body, and also the headers, it means that Lambda is responsible for returning that.
Okay, so because we've got the proxy plus turned on,
yeah,
we have some responsibility So how's that going to work? I mean, we've got 2 minutes left here. So
yeah, it's okay. So let's say I'm building this from scratch.
A little cores 101.
Yeah. So this is how API Gateway does. You can do the authorization, the method request, do anything you want before you call your backend. Then you call your backend, which is integration request. Because we're using Lambda proxy in this case, the integration response is actually grayed out. We cannot make that change. So what we could do here, if we're not want to use Lambda proxy, we could wire all of this manually using Swagger or Apache Velocity, and we would change the integration response and say, whatever the backend replied, I want you to add these particular headers. So that is good from one way, but also that it becomes clunky in the sense that now you don't control, you have it on an API, you decouple that core's functionality, but if you have to change something, you need to make a new API deployment and keep track of that. So it's a different type of beast to actually deal with.
Okay.
But it's totally possible to do.
And in a real world environment, how many Lambda functions that customers build are aware that they're connected to an API gateway versus they're just a Lambda function that receives some input, provides some output?
So in that sense, when you look at the template itself, what we recommend is that the functions that are in the same template, they're all of them going to be aware that it's going to be invoked by an API, right? If let's say you have an account A, I'm just kind of typing here to make it easier, and then you have an account B over here. So you have an API gateway already defined. Let's call this a checkout service, and then you have Lambda 1, Lambda 2 to do some validations before checkout, whatever that is. Once that service is complete, you want to tell to the user that you want to notify the user that the checkout has been completed, and you may want to kick off something in the warehouse, right? So you will have something similar again when you have another Lambda, another function, etc. These functions, because they're self-contained in the same template, they are aware that they're going to be called by API gateway. And these Lambdas, they need to call another API gateway somewhere else, then you need to inject this into CloudFormation stack or parameter store, something like this. How are they aware of the fact that this is happening? You can do it in two ways. Inside the Lambda, you see the events. You can have a schema validation library. In Python, there's a bunch of those that you can do something like this. Let's say your schema validator, do something like this. That you can say validate event against a API gateway schema. So if that's not valid, if that came from SNS or something else, you could stop the code right there. And that's something you could do. And that actually, in fact, is something that security partners like PureSec or Twistlock or many others are actually working like that. They're trying to make sure that the Lambda function only gets invoked by the event source you configure.
Right. Okay.
So for now, you can totally create anything like that. Because Lambda is just a function. You can do anything you want.
Okay, cool. Thank you.
Okay, so let's have a look. And fingers crossed. And apologies for that. Maybe.
Are you hitting the right endpoint?
Maybe I am. All right. We failed actually. Why did it fail? Let me see. So you failed at an API gateway. So let me have a look. That's not helpful. So that's actually
invalid mapping expression.
So errors found in unable to put response options for the resource path at encrypt invalid mapping expression validation result. Post options. So that is the course for sure. So why did that fail? Anyone can spot something weird here? So allow methods is allowing actually posts and options, which you should. And the content type and the localhost. So this is what it's complaining actually. It's complaining about the allow methods. Invalid map expression. So let's have a look at the example that we have in exam because it does look good to me. So let's look at the template. Where is the globals? Okay, so the course is just defining a simple course. It's not helping my cause right now, but let's actually find out in the versions. If anyone spots something ridiculously stupid on my hand, please let me know. So this is what the documentation says we should do, right? So,
Oh, you missed your double quotes.
The documentation tells us, right?
When in doubt, more quotes.
The good news is that now we have all at once.
By popular demand.
Yeah.
Can't blame them. I don't like waiting for anything either.
No, me neither. So I just want to prove a point. So let's actually drop this right now, make a deployment. and let's see this actually getting done. I guess the cool part of actually failing is that you kind of learn how to troubleshoot. And I think that's quite valuable, especially when you're looking at the docs, there are areas that we should highlight, or even silly mistakes like this, right?
That's gives us a good opportunity to mention the open sourcing of the documentation as well, right?
That's really cool. Yeah, absolutely. I don't know how many people saw this, but we have actually some cool stuff coming out in that sense about Twitch and everything. Sam is now all of these pieces about the template, the serverless function, and all of this stuff in general. This is actually going to be this is actually already is open source, and we had a Twitch recently that actually explained how this is covered. If you look at SAM translator, you will see everything that SAM is actually doing. So SAM in this case is actually looking at DSL, converting to CloudFormation standard in the way that this SAM translator is doing, so CloudFormation can deploy. If you look at model, just in case, we see all of this here. If you look at, let's say, lambda.py, you see a bunch of code that's actually going to be converted into proper CloudFormation, and there's you see all those permissions that we actually write behind the scenes for you on your behalf. Everything is actually here. So if I were to do a graph, we could spend probably more than a few hours just talking about this. But let's actually leave it at that for now. So thank you. So the updates worked, and we now have, we should have a API gateway with cores enabled. We got it working. Wow, at least from the console. If we now click an integration response, because that's what we're responding as a pre-flight, just to show you the magic, it's not something you should do. If you click in here, you will find the header mappings. It's exactly what we actually passed.
Okay.
So in theory, we have cores in our function, we have cores in our API gateway. So let's actually try this. So let me go back in here, use the CLI, because I don't want to keep showing more of the console. I just want to describe as I actually just need my profile. If I do this, I should have API gateway URL. I like CLIs. I like console, I'm sorry. So if we go now to our, I think we haven't changed the API. So let's go back in here and go to this and try. Yes! I was actually afraid of that one. I was like, oh my God, hopefully it's gonna work. So now we can see that we return a 200 application JSON. It was a post, and we can see the URL from here. And if we were to implement decrypt, it would be just a reverse, but that would just be exactly the same thing. Mm-hmm. So now we can send as many. If we were to try to decrypt this, we could try, but maybe it just kind of takes some time for me. Now, right now, we could probably focus on something else. But this gives you the idea of how all of this works. If you are interested about the decrypt piece, the decrypt is nothing more but this. I'm so happy that it worked. If we see the decrypt function, which is another PY, but much simplified, is we just run a .decrypt past the cipher blob, and we just get the plaintext. That's it. So that is not that difficult to implement. So if we go back in here, let's see what we got actually so far. We covered, if you're actually getting here right now, we covered the Serverless Application Repository, which is a service you can browse applications and publish. We talked about SAM, or Serverless Application Repository, that allows you to design all your serverless application, how your function, your application should behave, who's going to call your application, what permissions it needs. We went through the SAM Git repository, some of the SAM examples. We went to the cookie cutter, which is an open source solution that allows you to scaffold anything you want, any language. So we did one just for SAM Python applications to make it easier for you. We went through the SAM template definition, what all of those options meant, the structure of our files, how we scaffolded, and then we obviously installed applications, dependencies, local testing, code something from scratch. We deployed multiple deployment operations, API gateway, also look at Xray, and we actually now have done the front end.
Ticked off just about everything you wanted to do today. I'm
Absolutely.
Really impressed.
Absolutely. So the last thing, if we have time, is in case nobody has any questions or comments on this, we could make this application, at least for now, just to show you how would it be to publish this in the Serverless Application repository.
Yeah, let's do it.
Okay. So what Serverless Application repository, if you go to this URI, this is only for publishers, right? We will go for the server. We can go to the documentation in a minute. This will tell me how I want to publish an application. So I would go here in the publish an application. I could say encryption proxy sample. Of course, I will do some tidy up afterwards and publish them. So I could say Heitor Lessa and JSON Barto. Sadly, we don't have any web page. So maybe we just say where this is, right? And then we can say is encryption proxy sample, blah, blah, blah. We want to say some labels. So it's Python, encryption, maybe security, maybe a proxy, right? And the license, we could choose MIT because we're cool. And then we can also define some README or some explanations in there. So for now, we're just gonna leave as that. And we also need to define a semantic. So maybe 1.0.0, right? And where the code is, well, same as before. So I just actually do this. And then we have to say where our SAM template is. The key here is that Serverless Application Repository needs to know where is our zip file, where is our application. So we need to do this. Mm-hmm. So what we're going to do there right now is we're going to go to the docs because I don't know what permissions looks like. If I go to Serverless Application Repository documentation, I'll find out here, go to the developer guide, and I want to publish an application. So it explains everything I need, account, SAM, etc. It talks about this. I need to publish this to a Git, to S3, where similar to the way CloudFormation would deploy, it's the same way, but I need to make that public if I want to make the application public. So I need to give permission to Serverless Application Repository to look at my S3 bucket. So it can actually read the artifact and then publish that, right?
Okay.
So if we go to our package.yaml, we even already have the latest version here. So I can just use this, right? So the SAM bucket we need to give permission to SAM repos, application repo is this one. So we go here, go to S3, and then we look up for SEU West 1, and I can give a permissions. So in that sense, I want to add a bucket policy, right? And it asks me, what is my Git bucket? Let me know if that doesn't make any sense. So what this will allow is, we will allow Serverless Application Repository to look at my package, artifact, already has my application running, and deploy on someone else's account because I'm going to make that public in that sense, right? Okay, so if the docs are right, I should have my account, I have it, I have a SAM, I have a package, I have a URL pointing to my code, I have a README, I have a license, and I have a policy. So that's it. Let's go there back here and let's go back here in the browser, and we have to pass. Go back in here, demos. Now you're gonna see my secret.
The secret is that there is no secret, right?
My secret folders. I need to pass my package.yaml because that's where my zip files are, right? So I do this, and then, well, hopefully I have permission to do this. Oh, invalid name. So maybe I...
In the author. It doesn't like the, yeah, there you go.
Maybe a true hipster, right? Name contains invalid characters. What is it? Is that name? Like camel case?
Probably.
You form part of the ARN. So because it's an ARN, it's not going to work out. Yeah, that's me being silly. Yes. So now, oops. Oh, okay. So that's not going to work out for this example though.
Good to know.
So Serverless Application Repository actually allows a subset of resources you can do in SAM. Because you're using KMS key, and that's a little bit more complex in terms of setup, application repository is not allowing me to do it. So in this case, it's not going to work out for me to publish this application.
Okay, so what resource? So we were embedding CloudFormation language in a SAM template. What is in the scope of SAM? What resources can I use as part of my sample project?
Sure.
If I want to publish it.
Absolutely. So the good news about this, about SAM, is that not only you can add the SAM properties over here, your resources, but you can also add anything that CloudFormations understand. Mm-hmm. Remember the discussion about this? Account A gets API gateway, this and this and this. This is something super cool we could do. We could look up for CloudFormation parameter, and to finish it up, we could simply add a new resource over here that would say export encryption API. And from here, we could actually say, so that we can finish that up, we could say dev encryption /API /endpoint. And then as a value, we could do this. So now in my other template, in my other account, I can simply add a parameter that will use this and find the right API, and I can inject as environment variable in my next function or something. Okay. So now I can have cross-account in a different way in that sense, without having to depend on one another.
And the serverless application repository, when you were trying to upload just now, it was saying something about the KMS key. What was that error?
Yeah, so that's something I would need to investigate. So okay. What this tells me is the resource encryption P, because it's a KMS key, it's not supported, and therefore, just for serverless application repository, it's not allowed. Okay. So maybe there's something in the docs that I should know more about it, maybe in the limits or in the troubleshooting, which is something I would actually have to know.
Okay. All right. Well, we'll have to take that one away for a follow-up action.
Absolutely. So that's it for today. We're definitely going to do a follow-up because a lot of people actually asked. We're going to do one just for authentication. You are more than welcome to join me again. We can extend where we got left, and then we can just do authentication and everything. What we just got so far, if for those of you who just couldn't see the beginning, we are giving you a tool that all of this SAM template configuration that we are actually doing have to learn from the docs. We're giving you a cookie cutter, once you install cookie cutter as a tool, that you can essentially get all of this pretty much for free. Mm-hmm. So I can do something like tweet sample. I could add API gateway, I want Xray, I want safe deployments and canaries, and I may want to have a canary. So in this case, I already had this tweet sample. Mm-hmm. So it creates all of this for you, all this scaffolding, where the function should be, where the testing should be, and all that stuff as well. Okay. So hopefully that was useful. Hopefully you learned something from today. And yeah, keep actually tuned in. We're definitely going to give you another date when we have a follow-up of this, when we implement an authorization and we go down some specifics you may want to do.
Cool. And after today, if you want to build additional projects or just learn more, there's the serverless examples that's hosted on GitHub, the serverless application repository that has loads of examples published both by AWS as well as a lot of users of AWS. And Wild Rides, I think, is also probably worth mentioning as well as another example of serverless application technology.
Yeah. So, because we are a little bit past on time, if you are interested in getting hands-on experience on your own time, on your own pace, This is a workshop you can run. It's going to run on your own AWS account. It's going to give you a way better in-depth about everything we talked about today. From authorization perspective, from building a web app, processing data into a stream, or doing SAM, some local in more details and all that stuff.
Cool.
So that's for free. That's over there, available to you.
All right. Thank you very much, Heitor.
Thanks for having us, and thank you, Jason, for all the help as well.
Sure.
Thank you, everyone.
Take care,
Have
everybody.
a nice one. Bye-bye.